We're going to begin a study on hyperbolas. It is the last of the conic sections that we have been learning. We are using a combination of section 9.5 and 9.6 from the textbook. The definition of a hyperbola is the set of all points P in the plane such that the difference between the distances from P to fixed points, the foci, is a given constant. Unlike ellipses, where we can easily do a sketch of this, this is a little more difficult because of the differences, but as a result of the difference between the distances, our curve is going to point a different direction. So the equation of a hyperbola, much like the ellipse, tells you a lot about your graph. If you see the equation on the left begins with an x, that means automatically that our major axis is going to be the x. That doesn't mean that it's going to be wider that way, but that means that our two curves are going to point along that direction. And the same is true for the equation on the right. As in the case of all of our other conic sections, the center of a hyperbola is h and k, which are the values that are subtracted from x and y. In the equation on the left, if you look at the graph, I've already graphed the center of my hyperbola on the origin. Now the number a squared beneath the x tells me how many spaces to count to the left and the right. And what we're going to do is do that. So I've decided that my a is 3, which means the a squared would have been 9. And then I'll also count up and down for the b squared, which apparently I decided b squared was 4. So unlike the ellipse, where we would just draw our curve, what we're going to do here is sketch a box using those 4 dots. We're going to make a rectangle. And then we're going to use the diagonals of that rectangle going through the center of my hyperbola, and we're going to draw 2 asymptotes. Now all an asymptote is a guide to give our hyperbola the proper shape. An asymptote is an invisible line that you should not cross when you're graphing, and so that's going to keep us in line when we are graphing our hyperbola. So since the x comes first, our hyperbola is actually going to cross the x-axis, and it will not cross the y-axis, such as this. Okay, you see how that makes it looks like a parabola, and it's facing out. Well, the hyperbola is a mirror image of that, and so we're going to draw one exactly the same on the other side. And basically, our asymptote will keep the 2 hyperbola pieces in the right orientation. So if the x is crossed with the equation on the left, what do you think is going to happen with the equation on the right? So let's look at this. We're going to graph our center. This time I decided not to use the origin. And I've got my a's graphed, which apparently I decided was 1. And the b's are 2, and we're going to draw our box. Using the box as a guide, we will draw our asymptotes. Remember, the asymptotes are lines that we don't cross but use as a guide. And you can see these are a little bit wider than the asymptotes for the x major axis. Now, instead of crossing our x-axis, this one is going to open up along the y-axis, and let's graph part of that, just like that, and then we'll graph a mirror image on the bottom. And this is what the hyperbola looks like. Now, finding the foci is similar to the ellipse. In the ellipse, it was c squared is equal to a squared minus b squared. This time, you're going to add them using the Pythagorean theorem. So if the major axis is x, the foci, and you're going to add and subtract to the x and leave the y alone from your center. And if the major axis is y, you will instead be adding and subtracting c from your y coordinate. So it stays consistent. How to find the asymptotes? Well, we're simply just going to draw the box and draw the diagonals through the box. To graph hyperbolas with their center at HK, we have a few steps. We're going to begin, just like any conic section, by graphing the center at HK. From the center, you're going to count A spaces up and down. The A in your equation is actually squared, so you will need to take its square root. And you're going to begin with counting the A spaces up and down or left and right. If your equation begins with an X, it will be left and right. If your equation begins with a Y, it will be up and down. Third step, then we're going to count the other spaces from the other axis. But again, it's still from the center. Number 4, we will connect the 4 sides to form a box. You will draw your asymptotes by drawing a diagonal through the center and the corners of the box. And then the last, using the asymptotes as a guide, you're going to draw the hyperbola. So for our first example, we have a hyperbola in standard form, and we note that it is in standard form because the equation is equal to 1. We also know that it is a hyperbola and not an ellipse because we are subtracting as opposed to adding. So we are going to begin by finding the coordinates of the foci, and we're going to graph the hyperbola, and we're going to show the asymptotes as dashed lines, and we're also going to show the box. So in order to find the coordinates of the foci, we're going to begin with c squared is equal to a squared plus b squared. Now a squared is 9, b squared is 4. We don't have to square or square root for these, so we will simply add them. So that gives us c squared is 13, so c is equal to the square root of 13. Now the square root of 13 is the number that we will add and subtract to the x-coordinate of our center. And the x-coordinate of our center is 0. So we will add and subtract the square root of 13, and that will give us the foci. Now the next thing we're going to do is graph the hyperbola, and we will be showing the asymptotes as dashed lines. Now, the first thing that we're going to do is graph the center. That is the first thing that needs to be done. And the center is 0, 0. There are no numbers subtracted from x or y, so we are going to use 0, 0 as our center. And then we're going to count left and right because the x is the first coordinate, is the first variable in our formula. So the square root of 9 is 3. So we're going to count left and right 3 spaces. Then we are going to take the square root of 4, which is our b, and we will graph up and down 2 spaces from the center. Now we're going to use those 4 dots to draw a box, but remember those 4 dots are the center of the sides. They aren't the corners of our boxes. So we're going to draw a box using the 4 corners, like that. And then we're going to use the center of our box and the corners to draw the diagonals, which are called the asymptotes, like that. And then the last step is we are going to draw our hyperbola. Now remember to go back and check to see which variable comes first, because your hyperbola will open up along that axis, and it opens up along the x. And that is our hyperbola. Now for our second example, we're going to give the foci of the hyperbola y squared minus 4x squared equals 4, and we are going to put it into standard form first, and it is not in standard form because it's not equal to 1, and in order to be in standard form it must be equal to 1. So then we're going to graph it, and we're going to show the asymptotes as dashed lines. So we need to put this into standard form. And the way that we're going to do this is we're going to begin by dividing everything through by 4. Now you can see that in our second term with our x, we need to cancel those 4's. And that is our final equation of a hyperbola. So then we're going to find the foci. So in order to do that, we have got to find c. We're going to use this formula. Now a squared is under the y, and it's 4, and b squared, there's nothing there. That doesn't mean it's 0. That means it's 1. So then our c is going to be the square root of 5. Now since y comes first, it is the y-coordinate of the center that gets changed. And the y-coordinate of the center is 0. The x-coordinate is also 0. So we will have 0, negative square root 5, and 0, positive square root 5 as our foci. Now let's graph this. Okay, so I put on the slide the formula so that we can remember what we just found, and we're going to begin graphing our hyperbola, and we're going to begin with the center. So our center is 0, 0, and then we're going to move up and down along the y because the y comes first, and the square root of 4 is 2, so I'm put as one step counting a and b because that really is one step. So we're going to count up and down 2, and left and right 1, kind of a small box, and then we're going to make our box. Okay, our next step, we need our asymptotes because the asymptotes are our guide on how to shape the hyperbola. So let's draw those asymptotes. And then we're going to draw the hyperbola facing up and down and using those asymptotes as a guide for its shape. There's the top one, and there's the bottom one. Okay, we have one more example. Now the last example, we need to put this hyperbola into standard form. And as you can see, we are not going to have a center at 0, 0, which means we are going to need to complete the square before we can do anything. So we're going to put this into standard form, and I'm just writing the equation as we have it down right there. And the next step is we need to rearrange our terms, so collect our like terms, which includes moving the constant 19 over to the right. So we have our x's together and we have our y's together. Now we actually need to factor out the constants, and the x is fine. The x squared does not have a coefficient, that is not 1, but the y squared does. So we're going to need to factor out negative 4 from negative 4y squared and positive 16y. What you need to be careful of is when you are dividing that negative 4 from the positive 16, that you need to change that sign. So when you factor it, it looks like this. Now that we've got this factored, we are going to complete the square of our x's and our y's. Well, to complete the square of the x term, we just need to add a 1, but that 1 also must be added to the right side. So we're going to add it to the left side and to the right side. Now when we complete the square of y, on the inside of the parentheses, we're going to add a 4. But if we simply add a 4 to the right side, we are forgetting that that parentheses is being multiplied by a negative 4. So we're going to have a negative 4 times 4, like that. So our next step is we're going to factor and simplify. So we need to write these squares as squares and then simplify the right side by collecting all of the constants. And this is what our equation has simplified to be. So our last step is to divide by that 4, because to be in standard form, this equation has got to be equal to 1. So we're going to divide by 4. And there we have it. That is our equation in standard form. Now that it is in standard form, we know what a squared is, we know what b squared is, and then we can find c. Okay, so all we're going to do is add that 4 and the 1 to give us 5 and take the square root. Now we will be adding and subtracting that 5 from negative 1 because the x center is negative 1 and the y coordinate is 2. But since it's the x that we're concerned about right now, we will be adding and subtracting that square root of 5 from negative 1. So we have these coordinates. Now we can graph this. So our center is -1, 2. Now we're going to count the a and the b. Now a squared is 4, that means a is 2. And b squared, is 1, that means b is also 1. Okay, we're going to draw our box. Then we're going to draw the asymptotes. And then finally, we're going to draw the hyperbola. And it opens left and right because it's going to follow the direction of the x-axis. And that is the hyperbola.